Okay, so for this unit, we're going to be working on Unit 6, which is trig proofs and identities. For this one, specifically proofs. So here we have cos squared x is equal to cosecant x times cos x over tan x plus cotan x. So here we're going to work with the right side because it's more complicated. So first thing we're going to do is kind of change all of these out. So cosecant squared x, or cosecant x, can be changed into 1 over sine x right here. So we're going to do that. Then cos x, we're just going to leave. All over tan x. Tan x can be changed into sine x over cos x. So I'm going to do that. Okay. And then cotan x can be changed into cos x over sine x. So we're going to do that. Okay. Now we need to get the top of it, we can multiply out. So that will go to cos x over sine x. That's all going to be over this at the bottom, so we have to get a common denominator here. So cosine times sine to get this side, and sine times this bracket to get, or this fraction to get that. So here we're going to times this, so we're going to have sine squared x over cos x sine x plus, here we have times this all by cos x, so cos squared x over sine x cos x. Okay, now that we have common denominators, we can join the bottom, so we're going to rewrite at the top. So then sine squared x plus cos squared x over cos x sine x. Okay, so now sine squared x plus cos squared x here in the Pythagorean identities can be changed into 1. So we're going to rewrite that. Okay, now this is a division statement as this fraction line here states. So we're gonna write this out, cos x over sine x, and then we have to do the reciprocal of the bottom, which is times cos x sine x over 1. So now we're gonna have the sine x here cancel with that sine x, and we're left with cos squared x over 1, which is cos squared x, which if you look up at the top is what we had to start with. Okay, so that's the first question. Now to the second one. Here we have tan theta plus cotan theta is equal to secant theta cosecant theta. So for this question, what we're going to do is we're going to work with the left side of this to try and equal the right. So tan theta can be changed into sine x over cos x, or theta in this question. So sine theta over cos theta plus cotan theta changes into cos theta over sine theta. Okay, now we're going to have to get the common denominator, and so we're going to times the right side by cos theta and the left side by sine theta. So we get sine squared theta over cos theta sine theta plus cos squared theta over sine theta cos theta. Now the bottoms are the same, so we can join the top. Sine squared theta plus cos squared theta over cos theta sine theta. Now, as we said before, sine squared theta plus cos squared theta here in the Pythagorean identities can be changed into 1. So we're going to have 1 over cos theta sine theta. Now, here we can separate this out into two fractions. So 1 over cos theta times 1 over sine theta. And so then these can change. So 1 over cos theta here we can see is the same as secant theta. So we're going to write that in. Times 1 over sine theta here we can see changes into cosecant theta. So we're going to do that. Which, as you can see on the right side, if we write this down here, is the same as the left. Okay. Now onto the back side. We have one more question left. Sine theta times the brackets of cotan theta plus tan theta is equal to secant theta. So we're going to work the left side, seeing as that's more complicated. So then here we're going to write out cotan theta and tan theta in their changed forms. So we'll keep the sine theta on the outside. Keep that over 1. Bracket cotan theta we can change into 1 over tan theta. Actually, no, we're better off if we do it cotan theta equals cos theta over sine theta. So we'll rewrite that. My bad. Okay, and then tan theta is sine theta over cos theta, as we can see right here. Quotient identities. There we go. Okay. So now what we're going to do is multiply sine theta into this. So with distributive property, we're going to have cos theta sine theta over sine theta plus sine squared theta over cos theta. Okay. So now we have these two different fractions and with different denominators. So we need to get a common denominator so we can change this plus into one singular fraction. So here we're going to times the left side by cos theta and the right side by sine theta. So we'll go with the left side first. Cos squared theta sine theta over sine theta cos theta plus right side we're going to times by sine theta. For this purpose here, I'm just going to leave it outside rather than make it into sine cubed theta. And we're going to put that over sine theta cos theta. Okay, so now we can put these fractions into one. So we're going to do that. Cos squared theta sine theta plus sine squared theta sine theta over sine theta cos theta. Okay, so now here we have the option to take out a GCF. So in the top we see the GCF is sine theta. So sine theta outside of cos squared theta plus sine squared theta over sine theta cos theta. Now, as we can see on this page over here, cos squared theta plus sine squared theta is the same as 1. It's just in a different order. So we're going to write that as 1, which once you times that out by sine, you get just sine theta over sine theta cos theta. And then we can go and cancel out sine theta and sine theta, and we're left with 1 over cos theta, which if you look over here, 1 over cos theta can be changed into secant theta. We'll do that. And then on the right side, to start with, we had secant theta. We'll bring that down. And as you can see, these two are equal to each other.